take a look at solving open sentences involving absolute value. Recall that absolute value is the distance from 0 on a number line. So if I'm going to find the absolute value of 7, it is 7. But there is another number that has the same answer. What other number is 7 units from 0? Negative 7. The absolute value of negative 7 is also 7. So there are two problems that will give me the answer that they're of 7 when I take their absolute value. So that tells us there are going to be two cases to consider when we have an absolute value problem. The expression inside the symbol could be positive, or the expression inside the symbol could be negative. So if I were to say the absolute value of a number is 3, I know that there would be two answers to that. Either x could be 3, or in the second case, x could be negative 3. So these answers, when we are finding absolute value, we are going to be looking for two answers. Let's take a look at this problem. The absolute value of t minus 1 equals 5. Remember, I want to consider two cases. In case 1, either the expression inside t minus 1 could be 5. But in case 2, the expression inside t minus 1 could be negative 5. Because we know that both of those will give us, when we take the absolute value, we will get 5. If I solve the first one, t is 6. So I have two answers to this equation. Either t is 6 or t could be negative 4. And I could graph those numbers on the number line if I needed to. Let's take a look at the next one. The absolute value of 2x minus 7 equals 7. Do you know the two cases to write? Case 1, 2x minus 7 could be 7. In case 2, 2x minus 7 could be negative 7. Again, you solve each of the equations. Here, if I add 7 to both sides, it becomes 2x equals 0, so x equals 0. And my answers are 0 and 7. Can you plug those back in and verify that they work? 2 times 7 is 14. 14 minus 7 is 7, and the absolute value of 7 is 7. If I plug a 0 in, 2 times 0 is 0. 0 minus 7 is negative 7. And if I take the absolute value of negative 7, I get 7. Let's consider a couple other problems. The first one says the absolute value of x plus 3 equals negative 4. Sometimes students want to go ahead and solve this right away and write their two cases, but let's give it some further thought. Can I take the absolute value of any number and my answer is negative? This is a negative 4. No, distance is never negative, so there's not going to be any answer to this equation because there is no number whose absolute value would be negative 4. And the next one, the absolute value is not alone on its side of the equal sign. So in order to solve it, the first thing I would have to do is put it by itself, isolate it, and then I can begin to solve it. First, I would write my two cases. Either 5c minus 8 equals 12, or case 2, 5c minus 8 equals negative 12. Then I solve them. Two answers that will make this equation true. The last problem, I'm given a graph and I'm asked to write the open sentence of the absolute value equation. Well, one number is negative 4 and the other number is 6. They're not the same units distance away from 0. It would be easy if the dot were on 3 and negative 3, because then I could say, oh, well, the absolute value of x is 3, because they are both 3 units away from 0. But that's not the case in the example problem. They're not the same distance away from 0, but they are the same distance away from some number. So I'm going to find the midpoint of those two numbers. How do I find the midpoint? I add the two numbers up, and I divide it in half. Negative 4 and 6 are 2. 2 divided by 2 is 1. So they are equidistant from the number 1. And so this is the way I write the equation. I say that their distance from 1, the absolute value of their distance from 1 is, how far are they each from 1? 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. They're all each 5 units away from 1. So the absolute value of x minus 1 equals 5.